Good day to you. This is going to be an introduction to integration by substitution. We're going to probably spend some time with this, so this is just merely an intro. We'll practice some more. We'll probably spend some time doing more examples later. But the integrals that we've seen so far in our class have been pretty timid, okay? Meaning that there's really not much work to be done. You pretty much just do it. You integrate it and work backwards, and there's not too much to it. The problem becomes now when we have integrals that have products, like functions multiplied together, or even quotients, or compositions, okay? And so typically what we do, I'll write this down. So if the integral has products, quotients, or compositions, this is a very good method to use. And again, we'll outline it here in a moment. But another dead giveaway that you should be doing what we call a u-sub, okay? Integration by substitution, but u-sub for short. If you see that part of the integral is the derivative of another part, again, try a u-sub. Try a u-substitution. Okay, so this is kind of the framework. So if we see more complicated integrals, if we see quotients or products or compositions, or if it just kind of jumps out at us like, oh, this happens to be the derivative of this part of the integral, definitely going to be a u-substitution problem. Okay, so let's do 3 examples to kind of introduce what's going on here. Let's say we have the integral of 5x to the 4 over the square root of x to the 5th plus 2 dx. Okay, so far, our approach has been find the antiderivative, right? Work backwards. Looking at this, I would guess that you don't know what the antiderivative is. This is a pretty complicated looking function, okay? So next we see we got a quotient, and also notice that this part, the x to the 5th plus 2, okay, if I were to take the derivative of x to the 5th plus 2, I get 5x to the 4, okay? So 5x to the 4 is the derivative of x to the 5th plus 2, okay? And so what we're going to do is first we're going to define what u is. Second thing we're going to do is substitute the new variables. Then we're going to go ahead and integrate. And then we will change back to x, or the initial variable, whatever it might be. In this case, x. Okay, so now the question is going to be, well, how do I define u? Okay, so the part that has the derivative in it, we leave that alone. It's the other portion that's going to be u. Okay, so we're going to let u equal x to the 5th plus 2. Okay, the square root, we'll take care of that later, but it's more about what the function is on the inside. The second step is we're going to have to substitute new variables. Okay, In order to do that, we're going to take the derivative of this equation. So we're going to apply d dx. And when you do that, you get du dx equals 5x to the 4. Okay? And notice what I need right here. I have 5x to the 4 dx. If I move the dx to the other side, I have exactly the same thing. So I've just, with this substitution, I've established that du is exactly 5x to the 4 dx. Okay? And now I can go ahead and switch this integral over. So we're going to rewrite it. And this part in blue was actually just du. Okay? Here we have the square root of x to the 5 plus 2. But remember, x to the 5 plus 2, we define that to be u. And so when I change this over, I just have the integral of du over the square root of u. And maybe you're more comfortable seeing it written as 1 over the square root of u du. That's the same thing. Okay? And now we're just going to integrate this. So what have we been doing? Well, usually when we see a radical, we change it to an exponent, and since it's in the denominator, we're going to bring it up to the numerator and make it negative. So this is the same as the integral of u to the minus 1/2 du. And now these are the questions that we've been working with on the previous unit, right? So antiderivative, go the other way. So we're going to add 1/2, or I'm sorry, add 1 to the exponent to get positive 1/2. And then remember that we have to cancel out this 1/2 when I do the derivative, so that I get u to the minus 1/2. So it's going to be 2u to the 1/2 plus c. Okay? You should be comfortable going from here to this. Okay? The part that's new right now is changing variables from x's to u's and then just switching everything back. But that part's easy. How do I switch it back? Well, instead of u, we have that u is x to the 5th plus 2. So we're just going to replace u with x to the 5th plus 2. That's still to the 1/2, and we still have our constant of integration. So there you go. Okay? This is the antiderivative of this goofy looking thing. And again, it's very hard to kind of look at that and say, oh, this is my answer. So maybe you'll get there, but for now, u-substitution is the way to go. Okay? Here's a couple other examples. Let's say we have the integral of 2x cubed, 1 plus x to the 4 d, let's say that's cubed, by the way, dx. Okay? So I should say first, there is more than one way to do some of these. So you certainly could, figure out what 1 plus x to the 4 cubed is. In other words, multiply it out, FOIL it, whatever you want to do. It's going to be a long polynomial, and then distribute the 2x cubed, and then do the antiderivative. That'll get you to the same place. The problem is, it'll take a lot of time. Okay, since we have a product, okay, and a lot of times what you want to, especially when you see polynomials, or at least part of the integral features polynomials, right? See if the lower part, and what I mean by the lower part is this one, see if this is the derivative of anything else. And right now I notice that if I'd let u equal 1 plus x to the 4, then the derivative of that is going to be not quite 2x to the 3rd, but it'll at least get us the x cubed, right? Because if I take the derivative of x to the 4, I get 4x cubed. Okay? And so let's go ahead and figure out what du is going to be. And I should go back here real quick. It's totally fine if you go from u equals x to the 5th plus 2 and just write out du is going to be 5x to the 4th. Just don't forget that this needs the dx, right? Because technically you're differentiating both sides and then you're moving the dx to the other side. Okay, so over here, du would just be the derivative of this, which is 4x cubed dx. Okay, and so now we're here. We're not quite where we need to be because we would prefer, right? We want to get 2x cubed dx. And right now I have 4x cubed dx. Okay, so right here, we want this to be 2x cubed dx so that I can just swap that out. And so we can easily make that happen. Just multiply everything by 1/2. And so now I get that 1/2 du is going to be 2x cubed dx. And now we're ready to substitute everything in, okay? This portion, the 1 plus x to the 4 cubed, that's going to just be u cubed, okay? So I've taken care of this. And 2x cubed dx is 1/2 du, okay? So I'm just going to put the 1/2 out in front and then put the du where it's supposed to go. Remember, constants can be put in front just to make life easy. And then now what we do is focus on integrating u cubed. Well, we know how to do that. U cubed is going to become u to the 4th. And then we have to divide by 4 or multiply by a quarter to cancel out that exponent when I go back the other direction. And don't forget your constant of integration. Clean things up a little bit. That's going to be 1/8. And if you know where you're headed, right, we don't want to leave our answer with u. So let's replace u with what it was, which is 1 plus x to the 4. And that's to the 4th power. Don't forget your plus c, and there's your antiderivative. Okay? These do get easier with time. It does take practice. Lots of practice. These are very common integrals that u-substitutions show up on the AP exam frequently. Okay, so let's do one more, and we'll call it a day with notes. Let's go. Negative cosine of x times sine of x squared dx. Okay. So again, we don't know the antiderivative of minus cosine x sine squared. However, in here I have sine, and I know that the derivative of sine is cosine, so I kind of almost have the derivative out here. Okay, so let's let u equal sine of x. So that means du would be the derivative of sine of x, which is cosine x, dx. Okay, and our goal at this point is to get this to match. We want this to come out over here. And we almost have that. We just need a negative. So that's easily fixed. Just multiply this by -1. And so now we get minus du is going to be minus cosine x dx. All right, and now we can rewrite the integral. This portion is going to be u squared. The part in the orange boxes, minus cosine x dx, that is exactly what negative du is. I'm just going to put the constant out in front. We integrate. U squared will be u to the 3rd divided by 3 or times a 3rd plus your constant of integration. And now we just go back and replace u with sine of x. Okay, so this would be fine, or you'll probably see it written as -1/3 sine cubed x, either way. Okay, So hopefully this is making some sense. Again, it's going to take practice for you to get very fluid and quick when you do these problems, but we will be doing plenty of that. All right, have a good day. We'll see you guys in class.